Hello everybody and welcome back. We're looking at question 11 on the 2005 Pascal paper. If a, b, and c are positive integers with a times b equal to 13, well, if they're positive integers, one of these has got to be 13, one of them has to be 1. B times c is equal to 52. Well, I suppose you could have b as 1 and c as 52. But it's more likely that b is 13 here. And c times a is 4. The value of a times b times c is... So as I said, we can probably deduce that a is 1, b is 13, c is 4 without too much trouble, because 13 is a prime number. So if we wanted to, we could go that route. So what was it? A times b is 13. A times c was 4. B times c was 52. It's not that hard to see that a is 1, b is 13, and c is 52. Because they told us that they're positive, or not 52, 4. Because they told us that we've got positive integers. But we can actually do this problem without knowing a, b, and c, and without assuming that they're positive integers. Well, not assuming that they're integers. You do have to assume that they're positive, I think. Yeah. So, there's a great sort of trick you can do. You can, since these set of equations are what we call sort of symmetric, C appears in all but one, B appears in all but one equation, A appears in all but one equation. So how about we multiply all of these? So A times B, A times C, B times C. We're just going to sort of multiply on both sides. We'll get 2 a's, so we'll get a squared times b squared times c squared, and then we'll get 13 times 4 times 52. Now, you might not know 13 times 4 is 52, but you likely do, because there are 4 suits in a deck of cards and 13 cards per suit, ace through king. So 52 is actually a pretty common number for mathematicians, because we tend to like games, don't we? So we get 52 times 52, or 52 squared. Now, if we didn't have the condition that we've got positive integers, we could have some trouble here. Because what we want to do now is square root both sides and get a times b times c is, well, what's the square root of this? It's 52. But it could be plus or minus 52. But if a, b, and c are all positive, we can only have the positive 52 solution. Okay? But you could have a is minus 1, b is minus 13, c is minus 4, and these 3 equations would still work out, but you get minus 52 as your answer. But they told us positive, so that's all we need. We get 52 as our answer. Alternatively, you could just work out a, b, and c, multiply them together, you get 52 as well. So 52, that's E right there on the end. Okay. So that's question number 11. We've got question number 12 on the docket next. Join me for that one.